All right. So, hello and welcome everyone. I hope I'm live now. Is it audible to all of you? Wonderful. Welcome back to this particular channel of Pradhan Academy. So, I wish you are doing wonderful. So far, so good. So, we have been discussing on the JEE Means previous year question sessions, and in each of the session, we're basically discussing the top important previous year question that has been asked from that particular chapter. Right. So if you have been following me for a long time, then you must know that I have already started this particular series long back, and we have already discussed about the chapters of coordinate geometry. We have already covered algebra, and we have done the chapters of functions, limits, continuity, differentiability, and differentiation, and all this. And today we are going to apply all those concepts over here in the chapter of applications of derivative, right? So with this will mark the end of the differential calculus, and then we are going to start the integral calculus, right? So if you are new to this particular channel, I would request all of you to please hit the subscribe button, and don't forget to click on the bell icon so that you don't miss out any upcoming notification about the contents that we are basically trying to push on this particular channel, right? So I would also request you to please invite your friends, and please share these videos as much as possible with your friends and your people whom you know that they need these video lectures, right? These lectures are just for free on the YouTube, and you can definitely make the best use of it. Okay, so if you are preparing the sessions for, if you are actually attempting for this upcoming JEE Mains at part 2, then your these particular sessions are going to be really helpful for all of you. All right. So with this particular note, today we are back again with the topic of applications of derivative, right? So today's topic is application of derivative. And before we start on this particular session, I would like to request you to please make short notes. Okay. Now let me be very precise. The types of basically the things that actually help you in order to revise the syllabus, the entire syllabus quickly and in a very short form manner is basically by via short notes, right? Now, before you start with the sessions, I would always request all of you to please go through your NCRT. Please go through your NCRT as well as your NCRT exemplar, right? Because these two things are going to be really important for your JEE mains preparation. Okay. Now, once you're done with this particular part, then it's time to basically prepare the short notes and get ready for the chapter, and then we start to solve the JEE mains previous year questions. Okay, so if you have done with this particular preparation, and if you haven't prepared the short notes, then I would request all of you to please make sure that you make a short notes. Okay, so please make sure that you make short notes. Short notes are really useful for quick revision before the examination. Okay, so with this part, let's get started on our today's topic of applications of derivative. Okay, so today is our time to discuss about the application of derivative, and in today's session we are going to discuss the top important question that can be possible from the application derivative part, right? So let us start the today's session. So today our goal is basically to discuss about the applications of derivative part. We are also going to solve the previous year questions of JEE Mains. We are going to practice both numerical and MCQ type questions. We are also going to discuss about the types of questions that has been asked in the JEE advanced paper, right? And we are also going to predict what are the outcome of the paper. So if you look at this particular, if you look at the chapter of application derivative, and if you look at the yearly weightage every year, then you will find that this is very interesting, that you will find out that this is a very important chapter. Okay, so first and foremost thing that if you need to consider, I would say that please make sure that you revise this particular chapter and go for it, because it has lot of weightage. Okay, so if you look at this particular chapter, this has a lot of weightage. So if you just do the statistical analysis, which I have done, so I got the data that in 2024, there was an average of 1 to 3 questions. Okay, there was an average of 1 to 3 questions per paper. Okay, and in 2023, if you look at 2023 data, you will basically find it again the same, that is 2 to 3 questions. Okay, and if you look at 2022 paper, you will again find the question was around 3 to 4 questions. Okay, 3 to 4 questions. But 3 to 4 questions was basically clubbing with other particular topics as well. Okay, it was also the question from integral calculus as well, right? And some questions from differential equations were clubbed into it, right? So those kinds of question was there. So that's why 3 to 4 questions. And 2021, if you look at the pattern, then again it was like 2 to 3 questions. So this particular idea will basically give you a much broader sense of idea that basically this particular chapter is really important. Okay, now especially in this chapter, if you have to focus on the most important topics, I would say those are those are maxima and minima. Those are maxima, minima. Okay. The next topic that you need to prepare clearly is basically tangents and normals. Okay. Tangents and normal. And then there are lot of miscellaneous topics that can be framed from this particular chapter. Okay. I hope this part is clear, right? So this is the all the important topics that we have from the particular chapter, especially maximum minima is very, very important. Okay, maximum minima is very, very important because if you look at the previous year pattern, you will see mostly the questions were generally framed from maxima and minima part, right? So with this part, it's very important to discuss this particular chapter. So once you get this particular idea that this chapter is a very high priority and a high weightage topic, so it is worthwhile to prepare this chapter. Okay, and I will be starting to solve the questions. So before I take any questions, I will request you to please have a look and try to solve the questions, okay, by yourself. If you're able to solve it, I will say that you will get a immense confidence in your paper. Okay, so let's start with the very first question. The very first question is on your screen. Okay, so I would request all of you to please have a look and give it a try. Okay, so you can see there is a piecewise different function over here, and especially questions from piecewise different function is very, very interesting in terms of getting the local minimas and local maximas, right? So so the very first attempt that I would have discussed in this particular problem is basically try to plot the graph. Try to plot the graph of the function. Okay. So let us try to proceed with this question. Let us try to plot the graph of this particular problem. Okay. So what we can see that the function is piecewise defined, right? So let us try to plot the graph. So let us try to plot the graph over here. Okay. So in between, so there are multiple intervals. So when x is less than -1, it is basically 1 minus 2x. Okay. And there is one more interval -1 to 2 and then 2 to infinity, right? So if we look at the interval of x less than minus of 1, the graph is basically a straight line because 2, 1 minus 2, right? 2x. So if you put minus infinity, it is going to positive infinity, and at minus of 1, this value is equals to 3. So somewhere over here, let us call this value as 3. Okay. So this graph is like this with a negative slope. All right. And if you look at -1 to 2, the interval of -1 to 2, the graph is having again a linear function, but it has modulus in x. It has a modulus in x. So let's try to plot for the positive part. So if you try to plot that for the positive part, the equation will be simply like 7 plus 2x divided by 3. 7 plus 2x divided by 3. So let us see at x equals to 0, it is basically 7 by 3. Okay. At x equal to 0, it is basically 7 by 3 somewhere over here, and x equals to 2, and x equals to 2, it is basically 11 by 3. It is basically 11 by 3, something like this. Okay. So it is just going to be a repetition, but it won't go to that way. So if you put x equal to minus of 1, it is going to be 3. It is going to be equal to 3. So something like this, right? But the slope is different. Oh, sorry, the slope is same. The slope is same, right? The slope is going to be same. So a continuous part like that. Okay. Now at over here it is 7 by 3. So like this we will look, and if you will go above x equals to 2, okay, at above x equals to 2, the graph is something going to look like a parabola, right? And if you consider this parabola is going to have two roots, that is x equals to 4 and x equals to 5, and the minima is going to occur in between 4 and 5, that is basically at 9 by 2. And at 9 by 2, the value of y is basically coming out as minus 11 by 2. If you put this 9 by 2 over here in this particular equation, you're going to get minus 11 by 2. And the graph is going to look like something like this. Okay, this is 4 and this is 5, right? So the roots are like this. So once we get to this particular graph, now it is very simple and straightforward to all of us, right? Now, if we look at this particular graph, in this particular region, the local minima is occurring at x equal to 0. The local minima is occurring at x equal to 0. And similarly, in this particular region, the local minima is occurring at x equals to 9 by 2. X equals to 9 by 2, right? So therefore, if we look at this particular problem, so the local minima, it is basically asked to find the sum of the local minimum values. So if you have to find the sum of the local minimum value, that is 7 by 3 minus 11 by 2, that is going to be sum of the local minimum value. And if we just calculate this particular expression, it is going to be equal to 168 minus 11 by 72. Oh, very sorry. This is going to be minus 11 by 72. This is going to be minus 11 by 72. Okay, please correct this part. So yeah, fine. This is going to be 168 minus 11 by 72, and that's how we'll get the answer as 157 by 72. 157 by 72, and with this you will see option number B is going to be the correct answer for this particular problem. All right. So I hope this particular problem is clear to all of you. I hope this particular problem is clear to all of you. Please let me know if this particular part is clear or not. Okay. So as you can see, the question is fairly simple. Once you are able to do this question, once you are able to get to the graph of the question is fairly simple. Hi Ayush. Ayush Maheshwari, good morning. I hope you are doing good. Were you able to get the answer as option number B? Yes, Ayush. What's your answer? All right. So I hope this part is clear to all of you. I hope this part is clear to all of you. If you have any question, please let me know. If you have any question, please let me know. Okay. This problem is fairly simple in terms that we basically need to plot the graph of the function, and once we do that, the things of the local minima and maxima are clearly visible, right? So I hope you are also getting the same answer, right? And if you're watching the session after the live session is over, if you have any questions, you can always put that up in the comment section. Okay. I will really love to look at your comments and questions, and I will love to answer them. Okay. And if you want some personalized doubt clearance and you want to get a one-to-one interaction with me, you can definitely contact the number in the description box. Okay. So please make sure that you use all the resources well and prepare for the upcoming exam quite nicely, right? So if this part is clear, let's proceed with the next problem. Okay. So sometimes drawing the function is very beneficial. So that's why you have to have this particular idea. Whenever the piecewise different functions are there, please try to plot the graph. If it is feasible, try to plot the graph, and from the graph you can make a lot of inferences out of it. All right. So with this, let's move to the next problem. And the next problem is again our interesting problem on increasing decreasing function. So let me recall the concept of increasing decreasing. Okay, increasing or decreasing. So whenever you have an increasing function, for example, let y is equal to f of x be the given function, right? And you need to discuss about the increasing or decreasing interval. So for increasing interval, you will have to have f dash of x greater than 0. And since if it is strictly increasing, then it has to be greater than 0. But if nothing is mentioned about increasing, it's only mentioned, you can also equate that with f dash of x greater than or equal to 0. Similarly for decreasing, your first derivative should be negative. Your first derivative should be negative. That means the function is decreasing function. That means the slope is going to reduce. Is going to reduce, right? That's what you have to check it out from this particular part, right? Now, if you look at this problem, it is saying that 2 comma 3 with the largest open interval in which the function f of x is strictly increasing, and b comma c is basically the largest open interval in which the function g of x is strictly decreasing, right? So if you look at this particular problem, it's a very simple problem. You just need to perform the first derivative, right? So let me do this question over here. So y is equal to f of x. F of x is given as, so f of x is given as 2 times of natural log of x minus 2 minus x squared plus a times of x plus 1, right? And if we differentiate it once, so the value we are going to get it as 2 by x minus 2, 2 by x minus 2 minus of 2x plus of a. Now, if it is strictly increasing, it should be greater than 0, right? It should be greater than 0. It is strictly increasing, right? Now interestingly, if we do the second derivative, the result is going to be minus of 2 x minus 2 whole square minus of 2. Now, what do you get from it, right? If you see, square of any number is going to be positive, right? And minus of that will make it negative. Another, there is a minus over here. So from this particular part, from this very particular part, we are going to get f double dash of x as negative. F double dash of x as negative. Now, once you have the f double dash of x negative, that basically means the f dash function is a decreasing function. F dash function is a decreasing function, right? So it is basically means that the function is concave downward, and it is f dash of x is a decreasing function. So if f dash of x is a decreasing function and I need to have f of x as strictly increasing, then the condition is basically it is then the condition is that at the lowest value, so it is 2 comma 3, right? So therefore at f of 3 it should be greater than 0. It should be greater than 0, right? Because and f of 2, if you just try to understand the part, what I'm doing is that now since f dash of x is a negative, it's decreasing function, right? So at f dash of x at x equal to 3 will have the minimum value, right? And it should be greater than 0. It should be greater than 0. Now from this particular part, we are going to have 2 minus 6 plus a should be greater than 0. So from here, you'll get the a should be greater than or equal to 4. From here, you'll get the value of a should be greater than or equal to 4. Now, how did I make this prediction? If you put x equals to 2, this particular value, so at log of 0 is basically going to be minus of infinity, right? So at x equal to 2, it is minus infinity, right? So, and this particular f dash is a decreasing function. F of x is an increasing function. So f at x equals 2, if it is minus infinity, then at x equals 3, it must be a higher value so that it is a strictly increasing function, right? And if you put x equals 3, it should be greater than 0, right? I hope this particular part is clear to you. Okay. Therefore, from here, I'll get the minimum value of a as equals to 4. Okay. Now, it is said that b comma c is the largest open interval in which the g of x is increasing, right? Sorry, decreasing, strictly decreasing. So if I have g of x, it is defined as x minus 1 cube. It is defined as x minus 1 cube into x plus 2 minus of a, x plus 2 minus of a whole square. And if you do the first derivative of it, you are going to get the answer as x minus 1 whole cube into 2 times of x plus 2 minus of a plus x minus 2 whole square, 3 times of x minus 2 whole square plus x plus 2 minus of a, right? And this particular thing should be less than 0 because it is strictly decreasing. And if you do simplify this part, it is going to be x minus 1 cube, x minus 1. So we can take x minus 1 square as common and x minus 2 over here and in multiplied with x minus 8, right? Because we got the minimum value of a as 4, and from this it is going to be less than 0. Therefore, from this particular part, this particular interval is less than 0 for x belongs to 8 by 5 comma 2. For x belongs to 8 by 5 comma 2, right? So this is the two interval we are going to have. So once we get the value of a, and then from here this is going to be a b and this is going to be a c. So therefore we have to calculate the expression 100 times of a plus b plus c, and that is going to be equal to 360. Okay, that is going to be equal to 360. I hope this part is clear to all of you. Okay. So with this, option number A is going to be the correct answer for this particular problem. I hope you are also getting the same answer. Okay. So please let me know if this is clear or not. Please let me know if this particular part is clear or not. All right. So with this part, I hope you're also getting the same answer. I hope you are getting the same answer. All right. Please let me know if you have any questions. Please let me know if you have any questions. Okay. Or else we can proceed with the next problem. Or else we shall proceed with the next problem. So I'm assuming that this particular part is clear to all of you. So let's proceed with the next problem. So the next problem over here is that we are given a particular region. So as you can see, the region over here is defined by R and is consisting of all the points x, y such that it is following these two inequalities, right? So if we try to, first of all, let us try to plot this particular region. Okay, let us try to see what this particular region is giving implies to, right? So if we look at this particular region over here, the region R is defined as the region of y is greater than x and y is less than 9 minus 11 by 3 x square. So as you can see, the y is bounded between two functions, right? So one, we will take this particular part and we try to plot the inequality over here, and then we take this particular part and we plot the inequality out there. So let us see what this part is going to imply. So first of all, let us try to draw the region over here. Okay. All right. So let us try to understand. First of all, x equals to y is this particular line, the straight line passing to the origin, right? And if y is greater than x, so this is basically talking about this particular region. And similarly, y is less than 9 minus 11 by 3 x cube, 11 by 3 x cube, then this is going to be a parabola opening up downward, right? Opening downward, and at x equals to 0, the value is 9. And at x equals to 0, the value is particularly value the 9, right? So like this kind of. So therefore, the region that the question is talking about is this particular region. Okay. The question is talking about this particular interior region. Now we have to put inside a rectangle which will have the largest rectangle of the sides parallel to the coordinate axis. So that is only possible if I take a rectangle like this way. Let me take a different color, and if I take a rectangle like this, it is going to be parallel to the coordinate axis, as well as it is going to have the maximum area. It is going to have the maximum area. I hope this is clear, right? This part is clear, right? Now, if we recall the part we have discussed in the chapter of parabola, that is something called as parametric coordinate, right? So this particular line is y is equal to x, and this is basically 9 minus 11 by 3 x square. Now there is something called as parametric coordinate. So let us try to understand how we define a parametric coordinate. So let us say any point on the parabola can be defined as t comma 9 minus 11 by 3 t square, t comma 9 minus 11 by 3 t square. That is how we define a parametric coordinate, right? So from here, if we try to find out the area of this particular triangle, from here, we are going to have it as the area. So if we consider any point on this straight line, so we can consider any point in the straight line as t comma t, right? And this is going to be equal to, so since this t, this is going to be equal to 0 comma t, right? And this particular point is going to have the same y, so this point is also going to be equal to 9 minus 3 t square, and x is going to be 0. So 0 comma 9 minus 3 t square, that is going to be the coordinate. Once we have this, we can simply define the area. So the area is going to come out as, so if you just do this multiplication, that is the length into breadth, so that you're going to come out as 9t minus t square minus 11 by 3 t cube, minus 11 by 3 t cube. I hope this is making sense. Okay. Now once you have this area, and this unknown area is in terms of the parameter t. This unknown particular area is in terms of the parameter t. So let us try to write the problem, that is a in terms of t, that the area in terms of t is basically 9t minus t square minus 11 by 3 t cube. Now, in order to find the largest area, we have to first of all differentiate it once. Okay, so let us do it the maximum minima. So let us differentiate and try to get the critical point. So if we differentiate this one with respect to t, I'm going to have 9 minus 2t minus 11t square, 9 minus 2t minus 11t square. And if we equate this to 0, we are going to get the critical points. And if we equate this to 0, we are going to get the critical points, right? So that is going to be equal to 11t square plus 11t minus, plus 2t minus 9 is equals to 0, right? So from this, if we try to solve this quadratic equation, so we are going to get the two values of t, one as minus of 1 and other as 9 by 11. So if we just plot them on the number line, minus and 1 and 9 by 11, and we try to get the sign scheme of f dash of x, that is the dA by dt. Okay, and if we get this with the sign scheme, which will basically like minus plus and minus, because the t square term is dominated by minus sign over here, right? So from this you can see that whenever the first derivative, so this is basically the a dash of t. Okay, it is the sine scheme of a dash of t. Now, once the sign of a dash of t goes from positive to negative, so it is basically encountering a point of maxima. It is going from positive to negative, something like this. So therefore, this is t is equal to 9 by 11 is a maxima. So therefore, if we put t is equal to 9 by 11, we are definitely going to get the maximum area of the rectangle. Okay. So from here, the largest area is going to be equal to 9 by 11 multiplied with 9 minus 11 by 3, 9 minus 11 by 3. I hope, so let us try to put it over here. So 9 by 11, I'm taking it as common. So 9 minus, sorry, this is going to be 9 minus 9 by 11 minus 11 by 3 into 9 by 11 whole square, right? So once we simplify this, we're going to get the largest area as 567 divided by 121. So largest area is going to come out as 567 divided by 121. So from here, the option number B is going to be the correct answer to this particular problem. I hope this particular part is clear to all of you. Please let me know if this part is clear or not. Please let me know this particular part is clear or not. Okay. So I am expecting that this particular part is clear. Okay. Just a simple problem. So once we know the parametric format of writing any point in terms of one variable, then the question is fairly simple. We just need to differentiate it in order to get to the maxima and minima. Right. I hope this is clear. Okay. I'm expecting this part is clear to all of you. I'm expecting this particular part is clear to all of you. All right, let me go to your live chats. So, okay. If you have any questions, please put that up on the live chat. Okay. Now, these types of questions are really important because, first of all, you have to draw the region of the graph, and then you have to decide how to put in a rectangle inside it, right? So that it will have the largest area. The question might be also asked in the fashion that you have to find the minimum area, right? In that case, the value of the parameter t is going to be -1, right? But the t -1 basically won't be inside the region. Actually, if because it is said that x is greater than 0. But if I have defined the question in such a way that the x can be anything, right? In that case, you will be having a much bigger region. You'll be having much bigger region. I hope you can understand, right? If I would have defined this x is any real number, then this particular region will also come into, right? But since I have not defined x as anything, so x is basically said that it is greater than 0. So therefore, x cannot be anything. X should be greater than 0. So therefore, the only region that we have is this particular region, right? And in that particular region, t is equal to -1 is not a feasible part, right? So the minimum part is something else. Okay. So the question is framed in order to find the largest rectangle. Okay. I hope this is clear. Please let me know this particular part is clear or not. Okay. So let's proceed with the next problem then. So the next problem we have is another very interesting problem about the applications of derivative, right? So here we have to use the derivative as a rate measure. We have to use derivative as a rate measure. So if we look at the problem, it is said the a spherical chocolate ball has a layer of ice cream of uniform thickness. When the thickness of the ice cream is 1 centimeter, the ice cream melts at the rate of 81 centimeter cube per minute. The thickness of the ice cream layer decreases at the rate of 1 by 4 pi centimeter per minute. The surface area of the ball is at that particular instant. What is the surface area of the ball? So if we look at this problem over here, so let us say this is a spherical chocolate ball and it has a uniform thickness of uniform thickness of okay, it has a uniform thickness of ice cream. Okay, so this particular thickness is given as when this particular thickness is given as 1 centimeter, you have to find the surface area and the radius. Let us assume this is the radius. Okay, so if we try to find out the volume of the volume of this particular area, the volume of this particular spherical ice over here, because we have to basically find the rate of change of volume of the ice cream with respect to time. So from here, if we first of all find out what is the volume, so volume will come out as, so the volume of a sphere is basically given by 4 by 3 pi r cube, 4 by 3 pi r cube. So if we differentiate this volume with respect to time, or the rate of change of volume with respect to time, I'm going to get the answer as 4 by 4 pi r square into dr by dt, 4 pi r square into dr by dt, right? Now it is said that the rate of melting of the ice cream at the rate of 81 cubic centimeter per minute is equals to 4 pi r square dr by dt, which is given as 1 by 4 pi. So from this particular part, you are going to get the radius of this spherical chocolate with the ice cream is going to be 9 centimeters. So once you have the spherical radius of this chocolate, then surface area and the surface area is going to be equal to, 4 pi. So surface area of the without the ice cream you have to find out. So that is going to be 4 pi r minus 1 whole square, and that is going to be equal to 560 500 sorry 256 pi centimeter square, right? So with this, option number C is going to be the correct answer. So with this, option number C is going to be the correct answer. Sorry, option number D. Extremely sorry, option number D. So I hope this problem is very simple. It's just a simple question where we have to relate the volume with respect to the radius, and once we differentiate or try to take the rate of change of volume with respect to time, we are going to get the most answers, because we have the data and we just need to put and substitute for the values of, and to get out the values of the radius of the spherical chocolate with the ice cream. Okay, so this is the question, very simple question. So I would request, this type of question must be very simple. I would request all of you to please make sure that you focus on the chapters of this application derivative part, because the questions are not that difficult. Once you know the concept, of maximum minimum, once you know the concept of rate of change of uh, any quantity or derivative or the rate measure, so you are able to solve mostly the all the types of questions. Okay, so I hope this part is clear to all of you. Please let me know this particular part is clear or not. Please let me know this particular part is clear or not. All right, so I'm assuming this particular part is clear to all of you. So let's proceed with the next part then. Okay, so next part, we have another very interesting problem. Now, in this question, we are going to use the concept of Newton-Leibniz rule. Okay, we are going to use the concept of Newton-Leibniz rule. Okay, we're going to use the concept of Newton-Leibniz rule. So, if we look at the function, it is given in terms of a variable definite integral. It is given in terms of variable definite integral, which is going from 0 to x square, and the part to integrate is basically t square minus 8t plus 15 divided by e to the power t dt, right? And it is said that for all x belongs to real number, right? Now, from this particular part, we have to find out the number of local maxima and local minima of this function f. Now, in order to find the local maxima and local minima of this particular function f, we have to differentiate it, right? Now, I would like to recall the concept of Newton-Leibniz rule. So, whenever we have a variable definite integral, so let us say that I have a variable definite integral like g of x, which is going from phi of x to psi of x, and the integrand inside is given as f of t dt. Okay, now if we need to differentiate this g of x, then the value according to Newton-Leibniz rule is going to be equal to f of f of phi of x into psi dash of x minus f of phi of x into phi dash of x. Okay, so if we do this particular expression, you are going to get the result of the first derivative of the variable differential integral, right? I hope this part is clear. So once you apply this particular formula in this question, you can solve for the first derivative. So please try to solve this. Please try to solve this. Please try to solve this question. This is fairly simple problem. Please try to solve this question. This question is very simple. Okay. Please let me know what is the answer you're getting. Let me know the answer you're getting. So from here, if we first try to differentiate this, so from here, the first derivative of f of x will be equals to, so the first derivative of f of x is going to be equal to x to the power 4 minus 8x square plus of 15 divided by e to the power x square into 2 times of x minus 0, because f dash of 0 is going to be 0, so that is going to be the first derivative of x. So from here, we are going to get the answer as 2 times of x into x to the power 4 minus 8x square plus of 15 whole divided by e to the power x square. Right. Now, e to the power x squared is always a positive function, is always a positive value. So therefore, in order to get to the f dash of x equals to 0, it is only possible when this numerator is equal to 0. So from here, we'll get the critical point as x equal to 0. The critical points we are having at x equal to 0, x equals to plus or minus root 3 and x equals to plus or minus root 5. X, because this particular part can factorize at x minus 3 and x square minus of 5. Okay, so from this part we are basically having total of 5 critical points. So if I just analyze them on the number line, so minus root 5, minus root 3, 0, root 3 and 5, root 5 over here, and we'll put a plus, minus, minus, plus and minus. So minus to plus is a point of minima, and we have 3 minimas and 2 maximas. We have 3 minimas and 2 maximas. All right. So from here we can see that we have 3 minima and 2 maxima. So therefore, your answer is going to be, so the maxima and minima are going to be 2, 3. That is option number C over here. That is going to be option number C over here. All right. Is this part clear to all of you? Is this particular part is clear to all of you? Please let me know. Is this part clear to all of you? Very simple problem. Okay, so as you can see, this question is very simple. Once you know the Newton-Leibniz rule, the question is fairly simple, and you can know how to differentiate this question and get to the answers. Okay, so once you differentiate it, then you do equal to 0 to get the critical points, and once you do the sign analysis of the f dash of x, so the first derivative of x, then you are going to get the maximum minimum point, right? So when it is changing from positive to negative, it is a maxima, and when the f dash of x changing from negative to positive, it is a minima. I hope this is clear. I hope this part is clear to all of you. Right? Is this clear to all of you? Is this part clear to all of you? So once we understand this, let's proceed to the next problem. And there are certain questions that I have included from the parts which are having miscellaneous, right? So if you look at this problem, in this problem, first of all, you have to find for the local maxima and local minima. And once you have the local maxima and local minima, you have to get to the roots of the particular equation. Considering that those are the roots of the equation, you have to find out what is the given quadratic equation that will satisfy those particular roots. So I hope this question is very simple. You have to first of all find the f dash of x and do the sign analysis, and from that you'll get maxima and minima, right? So from that you will get the maximum and minimum values. All right. So I hope you can solve this question. So let us keep this problem as a homework problem and let me know the answer you're giving in the comment sections. Okay. You can solve this question at your time and please let me know the answer you're getting in the comment section. Okay. And if you're watching the session after the live class is over, I would request all of you to please solve it immediately after the live class is over and let me know the answer in the comment section. All right. So be disciplined enough to solve this question. And if you want to get access to all the lecture materials, test series and short notes, you can definitely join the Telegram channel. The link is in the description. Okay, so we have some more homework problem. This is the second homework problem. This is the second homework problem. So with this, we are almost done. We are almost done with the today's session, right? So I have given two homework problems and please let me know the answers in the comment section. Okay. Now I have given this homework problem considering that these questions are very, very important for especially for your JEE mains part. So please try to practice these questions and come up with the answer and let me know the solutions in the comment sections. Okay. I will be very eager looking out for your solutions. Okay. So please take a screenshot. Please take a screenshot of this and this one and this one. Okay, take a screenshot and solve it and upload the solution after the class is over. All right. So with this, let us end our session over here. So today we have discussed some of the very important questions on the application derivative part. Now, especially in application derivative, what I said that maximum minima is going to be really, really important. So that must have seen from the given problems that you can see over here, right? The previous problems were mostly inclined towards maximum minima, right? Now, there are certain questions that I have to take up from the part of tangential normal, and that I will do in the upcoming sessions where we discuss the next particular parts. Okay. So with this, let us end our session over here. And thank you for giving your time to watch this particular session, and don't forget to hit the like button if you like this particular content, and also try to share this content among your friends so that your friends can also take the benefits of this particular free contents. All right, so with this, let us end our session over here and thank you.